So far, I have discussed data types of Python. So integer, float, list, arrays. Okay, and that's what we need in this class. There are some more like dictionary, tuple, but for you, just think of tuple as more like a list. Okay, there's some differences, but I will mention it maybe today a bit. Okay, so we discussed that. Now these objects, these data types have certain properties. Okay, and which is connected. I mean, that property I'm going to show you today. So mutable and immutable objects in Python. So we need to first understand what is a Python variable or Python object. In fact, everything in Python is object. Okay, so when you say x equal to 5, okay, so 5 is an object which is pointed to by x. Now please note that x can now be given a value 50, or x equal to 50.0 is allowed. So in C it is not allowed, no, because if something is integer, x is 5, then I cannot assign a float to that variable. Now I can also, so here Python has no fixed data type. Okay, a variable x can have integer, float, or string data type. Because Python we do not declare a fixed data type for a variable. Okay, so variable can be any type, and that's how variable declaration is not required. In fact, should not be done. I cannot say int x like in C or C++. So variables do not have fixed data type, which is a good thing as well as slightly unsafe, but that's how Python works. Now, Python variables are global. That means in a IPython terminal, I type x equal to 5. That 5, that x can be called anytime, anywhere. Okay, except those within functions. So I'm going to cover functions in the next class. So variables are declared within functions, and those are local variables to the function. Okay, so we'll get to that a bit later. So the exist till exit command. So x equal to 5, that x is there for till end, and but you can delete a variable by del variable or reset. So just say reset, then it will reset all the variables. Reset means it deletes everything. So often we work with several files, Python files, .py files, .py files. Okay, so if I declare a variable in one file, that variable is not available to the other file. Okay, so let's say in one file I say x equal to 5, y equal to 10. Now I create another file and I try to say print x. That won't work because x is declared elsewhere in some other file. If you want to do it, then you can do by import. So from file 1, import var. So import, I've been saying that you can import numpy, you can import scipy. Similarly, you can import a file. Okay, or so you can say from file 1 import all variables star. So anyway, we're not doing it at present, but we will do it a bit later. Now, this slide is very important. So Python data are objects. So what do I mean by this? So when I say x equal to 10, so 10 is an object. Okay, so x has no, x is not very, x doesn't have major sanctity, but 10 has a important role. 10. So 10 is object. So this 10 is object, and it is stored in some location, right? So this is a location 4477371824. This is the address of that location. Now, what is x? X is pointing to that object. So x basically contains the address. Okay, it stores the address of object 10. Okay, and x is pointing to that object. Okay, now it has severe ramifications or consequences. So just think of x is this variable is a label to the object. Okay, so basically there is an object whose name is given as x. Now let's x equal to 10. Now I look what I do. So ID is I forgot to tell you. So ID is identification. So it tells you the memory location. So where is it 10 stored? So it is this location. Okay, so 824. So in fact, I just made a picture. So this 10 object and x is pointing to it, and address of this is this. Now I do something else. So ID of x So ID of X is exactly the same. So X is giving you the address of that object. So X and 10 are interchangeable right now. So you can use X or 10. I create another, so I say ID 11, that means I created another object 11 and I want ID of that. So that is a new address. This is 856, the last 3 digits. So this is object 11. Now, of course, 10 and 11 are different objects. So we'll go to the next slide. Get size of this object 10. So this 10 is object. Huh? The 10 is, so what is size of this object? It's 28 bytes. So this is in bytes. It is not 4 bytes or 8 bytes. It's an integer, though, even though it is integer, it has bigger size because it contains more information, labels, what type of this, what is the variable type, and so on. Okay, so we don't get into it why it is 28, but it is an object. So object, if you know C++ or Java, object has more information than the data itself. So now let's do some more things. So I say y equal to x, x equal to 10, y equal to x. Okay, so y is another label for the same object. Now, so you look at this part, this 10, x is pointing to 10, and y is also pointing to 10. Okay, now in C or Fortran, if I wrote this, it would have created a new variable y with a location. So x and y will be at different locations. Okay, now please recall. Okay, C has when I say x equal to 10, there is a variable x on which 10 resides. 10 lives in that variable x. Okay, or when I say y equal to x, that means a new variable y will be created where x is or content of x is copied. Okay, but here it is not being done. If you look at ID of y, it is exactly same as ID of x. So both are same ID. Okay, so these are critical difference. So when I say, well, now this is a curious part. Please keep in mind when I say x equal to 100, what happens? ID of x is new ID. It's not 824, it is 704. So as soon as I create 100, the label x has moved from 10 to new variable, to the new object. Sorry, not new, to new object 100. So objects are primary. 10, 11, 100 live all the time. I can change the labels. So this label is secondary in Python. And so ID 100 is say these two are same. ID of 100 and ID of x is same. What about ID of y? ID of y is same as before, which is ID of y is this. It remains the same. So y has not been changed. So y is pointing to 10. Okay. So object 10 and 100 remain unchanged, and that is why. So you see, once I create an object, it is not destroyed. It is there until I use the variable delete, function delete or reset. They exist once you create them, and they can't be changed. Okay, so this is called immutable. So this 100 will remain as 100. Okay, so I can't do anything at 100. I'm going to show you the list how it differs. So when you see the list is mutable, list can change, but these objects can't change. Now more examples. So when I say x is 10, idx. Now let's do x equal to x squared. Okay. So what is x now? X is 100, right? So what is the ID of x now? New ID. Will it be same as this or will it be different? Somebody wants to make. I mean, okay. I don't have chat box. I can't see it right now. But you may think that in C, x ID should be same, right? I mean, I just store. I mean, I store x squared in the same location, but it's not the case in Python. So the x squared is a new object. Is 100 is new object. So now 100 has been created, and x will point to that object 100. So this is a new object 100, and its ID is new ID. So 728 is different than this ID. So objects are primary, and when I say variable x is basically labeled to that object. Now mutable objects are lists and arrays. They behave differently. So let's look at list A is 1, 2, 3. Okay. Now B equal to A. So B is a new label to that object 1, 2, 3. So B and A both point to the same object, which is a list, and its address is this. So ID of A will be and ID of B, both are same, is 512. This one, 512. Now we'll do pop. We'll pop one of these elements. So pop 1 from A. So I pop 1 means location 1. So index 0, index 1. So second element, which is object. I will pull pop 2. So I pop 2. Now it is a new object, no? When because A has, I mean, the 2 has been removed, so it is print AB is 1 3. So this is 1 3. Now what is ID of A and ID of B? ID of A and B are same as before. ID is not changed. You can see this ID is same as this ID. So when after it popped out, the list changed. Okay, so that is list. Had it been, I mean, I could not do that to integer or a float. Once it is 100, that 100 to 101, I can make it. If I say 100 x equal to 101 or x equal to x plus 1, it creates a new object. Okay, here it didn't create a new object. It basically redid that object. Okay, so I mean, sorry, it kept the same address. It just changed the object. So it's called mutable. Okay, so that's why list and arrays are called mutable. They are changeable. Okay, so that's why mutable objects. I just want to make a remark. There's a new object called tuple, a new variable, a new data type called tuple. Tuple is very much like list, except that it is immutable. List, the tuples can't change, and instead of square bracket, they are use a circular bracket. Okay, so but that's the only difference. So tuple is useful for some applications, but that's the difference. Now some strange things. So I have this x. So now I say ID of x is this 552. Now I say x equal to x squared. Now what happens here? Print x and x ID of x. So x is of course 149 because it's x squared, but ID of x has changed. So what has happened? This x squared is a new full. I mean, it's a new list altogether, totally. Now, so the new list doesn't write on the same location. It creates a new object, and its location is different. Okay, so x squared is a new object, new list, and that's why ID is different. However, if I made some changes on 1 or 2 elements, like if I say x1 equal to 5, so that makes it 153, and ID will not change. However, if I do full change of the, I mean, basically I say x equal to sin x or x equal to x squared, then I create a new object and ID is different. Now, just go to the last slide. Here, I want to make a copy of an array. Okay, so you need it sometimes. You need to make a copy. So you can use C equal to A colon. That's one thing you can do. Or C equal to A dot copy, bracket, A dot copy, bracket open, bracket close. So here, see the new object. C refers to new object 13. So it is not same as A, which is right now 13. Its address is 512. But when I say this, then it is a new object created, and it has new ID. Okay. So you need this function sometimes, or so you can use either A colon or A dot copy. Okay. So I'm done with this part. Okay. So basically, you need to keep in mind that we have mutable objects and immutable objects. Float and integer are immutable; they don't change. But list and arrays are mutable. Okay, so I can stop and take some questions right now. So one point I want to make is, why is list mutable? Because I think what Sayukta said, if I have big list or big arrays, in fact, I may work with 1 million elements of a list. Copying will take time and also take memory. So we don't want to copy arrays. So you are allowed to change the contents of a list or array.